Alright, so this is basically a continuation of the first video that I recorded. Okay, so we're going to do the second problem. So this is g of x equals the absolute value of negative 1/2 x times x plus 3. Okay, so this is the type of case, this is kind of interesting because it's not quite in this form yet. Okay, so the book will show you something different with like you might consider like horizontal compression or stretch, all that great stuff. I'm going to show you how to rewrite this equation. So you can rewrite this equation so you only consider vertical stretches or compressions. Okay, so if I were to rewrite this, all the negatives in an absolute value will become positive. All the negatives inside an absolute value will become positive. So this is going to be 1/2 x plus 3 plus 1. Now, if you have a positive factor inside an absolute value, you can pull out this factor. You can pull out this factor. This is going to be 1/2 x plus 3, absolute value of x plus 3 plus 1, just like that. Okay. So next, what I want to do is just follow that same step process. So now this is in the form that we see above. Okay, so step 1, I have my vertex. Okay, so I want to look for what my vertex is. Now one way to think about this is the same thing as 1/2 x minus a negative 3 plus 1. Okay, so this is going to be my h. My h is going to be a negative 3 and my k is going to be a 1. So do you see that? So this h is going to be negative 3 and my k is going to be 1. Okay. Now we want to plot a point to the left of the vertex and to the right of the vertex. So let's go and plot that point. So negative 3 comma 1 would look something like this. And we want to plot a point to the left of the vertex. So left of vertex, so let's say we choose x equals negative 5. We could choose any number that's less to the left, but I'm just choosing one, negative 5. Okay. Basically what we're going to do is we're going to plug this back into our original function. Now you could plug this into here and you should get the same result. I'm just going to put it in there just because, well, maybe if you guys simplify it, what if you make a mistake somewhere here? Well, hopefully that's not the case, but basically I'm just going to put it back into the original just because that's what we started with. So look something like this. Okay. So let's say I were to simplify this. Negative 5 plus 3 is going to be a negative 2. So absolute value of negative 1/2 times a negative 2 plus 1. Negative times negative becomes positive. This is going to be positive 1/2 times 2 plus 1. Now simplify this further. This is just going to be 1 plus 1. Oh, sorry, absolute value of 1 plus 1. Okay. This part here, absolute value of 1 is a positive 1. So this is just 1 plus 1 equals 2. If I were to graph that, if I were to plot that, we know that one of the points is negative 5 and the y is 2. Okay. Next, so we want to consider to the right of the vertex. So right of vertex. So what we know is that if we're going 2 units to the left of the vertex and our absolute value has to look the same on the left or as it does on the right, but it's just going to be a positive or negative slope on each. Basically, if we plug in, if we're going 2 units left, if we go 2 units right from the vertex, that's x equals negative 1. So we can try to prove this to see what our value is. So g of negative 1 is you just plug everything in there, plus 1. So here the absolute value is going to be negative 1/2. Negative 1 plus 3 is going to be a positive 2. Negative 1/2 times 2 is going to be a negative 1 plus 1. So if you have negatives in the absolute value, turn them positive. So this becomes just the absolute value of -1 is 1. So 1 plus 1 is 2. So now if we plot our point, our x-coordinate is -1 and our y-coordinate is 2. So if I were to plot these points, so -5, 2, and this is -1, 2. Now if we want to check our work, we know, look, if we look here, we know that the number in front here is our vertical compression. So we know we graphed it correct because we don't see a negative value in front. A negative value would make it flip over along the vertex. But it's just a positive number here, so it's just going to be shaped like that. Okay. Next problem. So g of x equals -1/5, and then the absolute value of x plus 6 plus 4. Okay, this one is going to be an interesting one. So instead of writing all these steps here, I'm just going to just do it out. So vertex, if I were to rewrite this equation, this is so g of x equals -1/5, and then this is going to be x minus a -6 plus 4. Okay, so our vertex, since it has to be a minus in the front like that, it's going to be -6, 4. -6, 4. That means we're going here and maybe up like that. That is our vertex. Okay. Step 2. Choose a point to the left of the vertex. So if you want to choose a point to the left of the vertex, maybe let's consider x equals -12. So we're gonna get some we might get some ugly numbers here. Okay. So I mean, that's the case when you do these absolute value graphing it. The calculations might be a little bit messy. Okay, so if you plot to the left of vertex, so basically g of -12 is going to be basically -1/5, and this is going to be -12 plus 6 plus 4. So -1/5. This is going to be -12 plus 6 is going to be a -6, and then plus 4. Negatives in the absolute value become positive. This is going to be -1/5 multiplied by 6 plus 4. Now if you do this on a calculator, 6 divided by 5 is a -1.2. So -1.2 plus 4 is going to be 2.8. So you're going to get some really ugly numbers, and you're going to have to try your best to graph, especially in some of the homework problems that I assigned. Some of them are not the greatest, but you might have to use your best judgment. So when x is -12, y is going to be 2.8. Okay, that's going to be the point to the left. So when x is -12, y is going to be about 2.8. So when you think about it, this point is lower than the other one, and if you think about it, that should make sense, because this negative in the front implies that if you have something like this, it's going to be flipped over. Okay, so it's going to be, it should be pointing, the absolute value should open downward. Let's do the other point. Let's say if we chose a point, let's see, what did we choose? -6. So if we chose a point 6 unit to the left, maybe let's try a point 6 units to the right of the vertex. So that would be -6 plus 6. Let's try x equals 0. This would be the point to the right. So plug in g of 0 equals -1/5, and then basically 0 plus 6 plus 4. This is -1/5. 0 plus 6 is a positive 6 plus 4. And if you look at this part is the same as this part on the left. That means if you do it out, it should come out the same. This part is going to be -1.2 plus 4. So it's going to be 2.8. Okay. So from here, if x is 0, y is going to be 2.8. And that basically confirms what we did earlier. So if x is 0, y is 2.8. Go ahead and graph this just like that. Something like that. Okay. Something like that. Alright. Now the fun problems. Okay. I'm only gonna go over 2 more problems, and that should summarize this lesson. Sorry, it was a bit longer than I thought. Okay, but anyway, so write the absolute value function in standard form of the graph. So standard form is this form I gave you earlier. So I'm going to rewrite that on the bottom. So f of x equals a, and then the absolute value of x minus h plus k. So you want to write this in standard form. So what we want to do is we want to identify the vertex, and we want to identify a point on the graph. So what if I'm just going to change this f of x just so you guys can see that we're going to identify a point, a known xy point on this absolute value. We need the vertex, and we just need to solve for a. Okay, so what we see here is we have our vertex. Our vertex hk is going to be 4, 3, right? 4 units to the right, 3 units up. So this part here, so y equals a. So I'll just write it out, and I'll just erase. So h is 4, the k is 3. Okay. Now we want to choose a known point. So what I see is that I know this point here, right? This looks like something that we know. Our xy that can be defined by the absolute value is going to be, let's see, I'll choose 0, 2. Okay, so here what we do is we know our y, this is 2. We know our x, that's going to be 0. And our goal is to solve for a. Okay, so from here, what we see, I'm going to fold this so you guys can see it. Okay, so from here, 0 minus 4, simplify that. That is going to be negative 4 plus 3. Turn this positive. So this is going to be a times 4, maybe I'll write it in parentheses, plus 3. And we want to solve for a. So subtract 3 on both sides. This is going to be negative 1 equals 4a. I'm going to write this up here. Negative 1 equals 4a. Our goal is to solve for a. Divide by 4 on both sides. A equals negative 1/4. Okay, so that means our absolute value in standard form, we know a, we know our vertex, so this is going to be y equals negative 1/4, and then the absolute value of x minus h, so h is 4 plus 3, just like that. Okay, I'm going to do the last problem, and that is it. Okay, so it's a word problem. Hopefully this will help you out. I believe with number 16, the one that I assigned for you guys. So while playing pool, player tries to shoot the 8 ball in the corner. So once you get to this corner here, it's really tiny. So if you imagine a coordinate plane that is placed over the pool table, we know that this 8 ball, we know that, let's see, the 8 ball is going to be there, I guess. So that point is going to be 5, 5/5. The player is going to bank the ball off the side at 6, 0. Sorry, you can't see that, but hopefully you get the gist of it. And the pocket that they're aiming for is up here. This is 10, 5. I guess the pool table is 10 feet wide and 5 feet, I guess that way. Anyway, so what we want to do is we want to write an equation for the ball. Use that same equation. So y equals a, and then absolute value of x minus h plus k, just like this. Okay. So we want to identify our vertex. So if you look at this problem, it's gonna, the 8 ball is here. It wants to bank off this one and go into the hole. Okay. So this is going to be the turning point or the vertex. So basically this is going to be 6, 0. So we know that y equals a x minus 6 plus 0. Now another way we could write this, 0 is kind of redundant. It's just going to disappear. So this is y equals a times absolute value of x minus 6. Okay, we know an x and y. So if we know an x and y, let's say we use this point right here. So 5 comma 5 fourths. Okay, so 5 comma 5 fourths, this is my x, this is my y. Okay, let's plug in the y, 5 fourths equals, this is going to be a, and then you're considering 5 minus 6. So this right here, 5 fourths equals a, and this part here is going to turn into a -1. Now absolute value of a negative number becomes positive. So this is 5 fourths equals just a, right? Because a times 1 would just be a. Now you want to write an equation for the path of the ball. Write an equation for the path of the ball. Y equals a and absolute value of x minus h plus k. A is 5 fourths, and we know our vertex. So our vertex is going to be just x minus 6. And don't need to put the 0, that's just redundant. This is my equation of the ball. Okay. Now, did the player make the shot? How do you know? So let's do that for fun. So did the player make the shot? The shot is at 10 comma 5. The shot is at 10 comma 5. And those of you wondering if I'm gonna buy a shot glass from California, maybe not gonna happen, but different kind of shot. Anyway, so this is going to be this is my equation. Y equals 5 over 4 absolute value of x minus 6. Okay, so this is the hole that I want to hit the 8 ball in. My y is 5, and then my x is 10. 10 minus 6. So checking to see if the two sides equal each other. This is 5 over 4, absolute value of 4. So basically this is 5 equals 5 over 4 times 4. 4 will cancel out, 5 equals 5. That's good. So did the player made the shot? And you can say yes, he did. Yes, because the left hand side equals the right hand side. Yep. Now yeah, if those two sides do not become equal, you'd probably need to check your work somewhere. But whew, done. That was a long part 2. I thought that was going to be shorter. But anyway, hopefully this helps, and hopefully you got through this video. That's cool. Alright, I'm going to do 2.2. 2.2 is probably going to be a lot faster than 2.1. This one took a while just because it's graphing. Okay, bye.